Welcome back. Today's objective is to factor trinomials in the form of ax squared plus bx plus c, where a, b, and c are integers and a is equal to 1. So that is ax squared plus bx plus c, where a, b, and c are all integers and a is equal to 1. In other words, problems that look like the ones you see before you: x squared plus 6x plus 8, x squared plus 5x plus 6, and x squared minus 9x plus 14. Notice there is no number out in front of our x's, and the numbers in front of our x are plain x's, and our number at the end are all integers. They can be positive or they can be negative. And we call these trinomials because there are 3 terms. We often refer to these type of problems as old-fashioned factoring because they're the simplest to compute, and they're the first that we generally learn. So let's look at a few problems here. I have some listed below. They're all different versions of themselves. We have plus 6 x plus 8, we have x squared minus 6x plus 8, we have x squared plus 6x minus 8, or we have x squared minus 6x minus 8. If we take a look at this first one, what we really are saying here are we want the factors of 8 that add to 6. So factors of 8 that add to 6. Factors of 8 include 8 and 1 and 2 and 4. So do we have any factors, and we're going to use add for this addition here, that can add to 6? Well, we'd be looking at 2 and 4. So when we factor these, we get x plus 2 and x plus 4. That would be a completed factoring problem. We can also look at the second one, and here we're looking at factors of 8 that are going to add to 6. Again, that's factors of 8 that are going to add to 6, but because it's a negative 6, they're both going to be negative. So we're going to get an x minus 2 and x minus 4. If we look at this next set here, we want factors of 8 that subtract to 6. Are there any factors of 8 that can subtract to 6? Well, if we do 8 minus 1, we get 7, or 1 minus 8 is negative 7. We can do 2 plus 2 minus 4 and get negative 2, or 4 minus 2 and get positive 2. So that since this can't be done, we call it prime. Take a minute and decide if you can factor x squared minus 6x minus 8, or if that is prime. Good, so there are no factors of 8 that subtract to negative 6, so this one is prime as well. If it can't be done, we often call it prime. So I want you to take a moment to relate what we already know about the word prime to this new use of the word. Go ahead and pause your video and think about this question, as it may be asked on a quiz later. All right, now I want to take some time to look at how to check if we factored correctly. So in the first problem, we found that x plus 2 and x plus 4 are the factors of x squared plus 6x plus 8. And since we can define a factor as being 2 values that are multiplied together to give us some other number, we can actually check by going back through and foiling. Remember, to FOIL means to multiply your first, x times x is x squared, your outers, so x times 4 is going to be 4x, your innards, which is going to be a plus 2x, and your lasts, which is an 8. Then we want to combine like terms, and when we do that, we get 6x squared plus 6x plus 8, which was our original problem. So you can always do this after you're done factoring to check back through that you did it correctly. I want to pause and take another minute here to just say, what are these factors? What do they represent? What information does it tell us about our graph? Pause the video now and go explore the answers to these questions again because they might show up on a quiz later. Go ahead and pause the video now. Welcome back. I want to do one more where we have to find the GCF first. That's because GCF should always be our first move. So let's look at this 2c cubed plus 10c squared plus 12c. I want to first find the GCF of all of our coefficients. Again, the coefficients are the numbers next to our variables. So if we're looking at 2, 10, and 12, we have a GCF of 2. Then we look at our variable terms where we have a c cubed, a c squared, and a c. And so those are each divisible by c. Next, in parentheses next to it, I want to say what's left over. So if we divide out a 2c by this 2c cubed, we're going to be left with a c squared. If we divide out from our 10c squared a 2c, we're going to be left with 5c. And if we divide our 12c by 2c, we're left over with just a 6. Now this matches our x squared plus bx plus c form that's going to tell us that we're allowed to do this old-fashioned factoring. So what we want to work with now is we know we're going to have a 2c, we never lose that, and then we're going to have two binomial factors. So what numbers, which factors of 6 add to 5? Well, 6 factors to 3 and 2 and 6 and 1. And so clearly 3 and 2 are going to be the choice for us. We want c plus 3 and c plus 2, since 3 plus 2 is equal to 5. And this would be our completed factoring problem. If we wanted to check this, of course, we could always FOIL back through and then multiply by our 2c, and we will get the resulting 2c cubed plus 10c squared plus 12c. And then something else that I want to point out is that we never lost this. 2c is a factor of this trinomial. This trinomial happens to have 3 factors, and we can write them in different orders if we wanted to. So 2c times c plus 3 times c plus 2 is the same thing as c plus 2 times c plus 3, as long as we include them all. Here we would have an x-intercept at -3. Here we would have an x-intercept at -2. And here we're going to have an x-intercept of 0. That's all that means. So again, anytime you see a trinomial in the form of ax squared plus bx plus c, where a is equal to 1, and therefore there is no number out in front of that x squared, you're going to want to go ahead and factor using this old-fashioned factoring method. Go ahead and try the Objective 3 practice problems that you can be found in this module, and then when you're ready and feel confident, you can try the quiz. Good luck.